Welcome all of you students for the new academic year. Today we can study or we are going to study one branch of science, physics. What is actually physics? Physics is the branch of science which deals with nature, properties of matter and energy. You know, this branch of physics consists of different topics such as electricity, magnetism, mechanics and so on. From this mechanics, we branched as one part dynamics. In that dynamics, a part is motion. First of all, you observe this one. This one is here yesterday, today and tomorrow also. This means its position is not changing. That means this one is at rest. Now, you got idea about what is the rest. Now, we are going to discuss about another term, motion. This is the first unit in our class. What is actually motion? If the position of a body changes with time, then we can say that body is under motion. There are different types of motion we know in our daily life. Among that, one is straight line motion, otherwise rectilinear motion. Then another type is rotation, revolution and also vibrational, etc. In this, first we can discuss about this straight line motion. It is the simplest form of motion. It is the simplest form of motion. See here, an object starts from O. Here, to represent motion or rest, we must consider a reference body or a reference point. With the help of only reference point, we can say a body is at rest or motion. To know more about reference points, in our text an example is given. A school is 2 km north from the railway station. 2 km north from the railway station. Here, railway station is the reference point. In the same way, when we consider straight line motion, we took reference point as origin. Reference point as origin. Here you see, a body starts from O and it reaches A through C and B. Suppose it returns from A to C again. Once again, a body starts from O and reaches at B through B and C, and then it returns to C. Now, the total distance traveled is equal to OA plus AC. Here OA is 60 meter, AC 35 meter, total 95 meter. This is the distance traveled by that body. Suppose if that body means from O to A, then again to O, then the total distance equal to, when returning to O, total distance is 60 plus 60 is equal to 120 meter. In the first case, distance, that means when the body returns to C, traveled 95 meter, but its distance between initial point and final point, its distance between initial point and final point OC is equal to 25 meter only. When it returns again, that it travels from O to A, returns to again O, the total distance traveled 120 meter, but the distance between initial position and the final position now becomes equal to 0. Now, this distance, that means straight line distance between initial points and final points, is the shortest distance and it is termed as displacement. Here displacement is 0. Initial point, final point, both are same. So, you want to remember what is displacement. What is actually distance and displacement difference? Distance means the total path traveled. But distance is the total path that the body traveled. But the displacement is the shortest distance. Once again, shortest distance between its initial position and final position. Okay, now we want to know about what is the difference between distance and displacement. Distance has only magnitude, that means it has only a length, not taking any direction. But we know displacement is the straight line distance between or shortest distance between initial point and final points. So displacement has a magnitude and direction. Displacement is the magnitude and direction. But distance is with only magnitude. That means only measurement. Another difference, this distance is a scalar quantity. That means a quantity with only magnitude. But the displacement is a vector. That means both magnitude and direction. Now, based on this, there is an activity given to you. Take a meter scale and a rod and start from one corner of a basketball court to another, then opposite corner you reach. Then by using the rope, the distance you measure. And again, that means the distance is OA plus AC. And then you take a displacement. Displacement is the straight line distance O to C. Is they are equal now? No. Because distance here is more, displacement less. That is the difference between distance and displacement in this case. Another activity you want to remember, you know, in vehicles to measure distance and also show speed, we use a device called odometer. What it is called? Odometer. Odometer is used to find distance traveled by a vehicle, for example car or lorry, etc. Okay. Now, from our experience and also from our knowledge, we can answer some questions given to you. A body travels certain distance. Can its displacement become zero? This is the question. A body travels to a certain distance. Can its displacement become zero? Yes or no? And you can give a reason for answer. Answer is yes, sir. Suppose a body starts from O and it reaches A. If it again returns to O, then its displacement is 0. But the distance travelled is here. That means distance travelled is there, but in this case displacement is 0. For example, a body starts from O, travels to A, then again returns to O. Or otherwise, a body travels a circular path, again returns to its starting point. In that case also there is distance but no displacement. Now, one more question is there. That is a farmer. He has got a square field. That is square field and each side of length 10 meter. A farmer, his field is a square and one side length is 10 meter. And 40 seconds he takes to travel from once this square field. 40 seconds will take to travel from once point to the all other route to again there. Then you want to find out in 2 minutes 20 seconds. 2 minutes 20 seconds, what is his displacement? 2 minutes 20 seconds, what is his displacement? You know, after 40 seconds, he comes to the starting point with O. Again another 40. Again another 40, he again comes to there. That means 80 seconds is over. Then again another 40, he again comes to the same point. Now, already 120 seconds, that means 2 minutes is over. 120 seconds, 2 minutes is over. Remaining 20 seconds, that means he will reach at this point. Now his displacement is the opposite side, that is the diagonal length. Now this is the displacement of him. That means this side is 10 and this side also 10 meter. So his displacement is 10 root 2 meter. That means you know what is this is a right triangle. Its hypotenuse square is equal to opposite side h square. Hypotenuse square is equal to opposite square is 10 square plus adjacent square 10 square. That is equal to hypotenuse square is equal to 100 plus 100 200. That is equal to hypotenuse equal to root 200. That is 2 into 100. That means 2 into 100. 100 root is 10 into root 2. That is the displacement. This displacement is 10 root 2 meter only. That is from this point to here only is displacement. Now, you want to find out one more things about the displacement. That is also a question given there. That is which of the following is true for displacement? Which of the following is true for displacement? First one is it cannot be zero. Displacement cannot be zero. Is it true? No, it is not true because displacement can be zero. When a body starts from one point again returns to there is no displacement. So displacement cannot be zero is zero. Displacement can be zero. Another one is magnitude of displacement is greater than distance. Magnitude of displacement is greater than distance. That is also not true. because magnitude of displacement is not greater than distance. So these are also wrong. Now we can learn more about motion. Among that one is uniform motion and another one is non-uniform motion. Once again, uniform motion and another one is a non-uniform motion. Observe the motion of two bodies A and B, and their time is also given. At 9:30, A travels to a distance of 20 meters. At 9:45, it travels from 10 to 20 meters. That means within the time difference is 15 meters. Within this 15 minutes, how much distance travel from 10 to 20? That means 10 meters is traveled. Again you see from 9:45 to 10, there is a time 15 minutes, distance 20 meters to 30. That is also 10 meters. Then next from 10 a.m. to 10:15 a.m. That is time is 15 meters itself. 15 minutes itself. Time is 15 minutes. Distance traveled is 30 to 40 minutes. 10 meters. In this way, you see again, if you repeat time, always we get 15 minutes. Distance traveled 10 meters itself. Here you see equal time 15, 15, 15. Distance traveled 10, 10, 10. That also equal. That means if a body travels equal displacement, equal distance, if a body travels equal distance in equal time, then we can say that motion as uniform motion. When a body travels equal distance, 10, 10, 10, 10. Time 15, 15 minutes, 15, 15. Time also equal, distance also equal. Such type of motion is called uniform motion. But here one thing we want to remember, the time must be short. We want to take a short time, not for a long time. The time we should consider smaller. Now, this is the motion of the body A. That means body A is moving with a uniform motion. Now, consider the case of B. B, time 15 minutes, but distance from 12 to 19. That means here 7 meter distance. Next also from time 15 minutes itself. But here distance 19 to 23. That means only 4 meters. Next time 10 a.m. to 10:15 a.m. That means the time difference is only, that means 15 minutes itself. 15 minutes. See here the displacement 23 to 35. That is 12 meters. One more we can take that means here that means 10:15 to 10:30. Here time is 15 minutes. Displacement is 35 to 37. Only 2. Now here time 15, 15, 15, 15. Time same. But the distance traveled only 7 meters. Another one is 4 meters, next one is 12, another one is 2 meters. From this, what we can understand, in equal time, travels unequal distance. Within equal time, 15 minutes 7 meters, 15 minutes 4 meters, 15 minutes 12 meters. In this way, when a body travels unequal distance in equal time, then it is called non-uniform motion. Then what is actually non-uniform motion? In equal time, if a body travels unequal distance, then that motion is non-uniform. Here the motion of body B is non-uniform. Okay? Now we want to measure a rate of motion. For that, suppose a cricket ball, but that a cricket ball bowled at a speed of 143 km per hour. 143 km per hour. Okay. What does it mean? This means if that ball is moving at a speed of this, it can travel to a distance of 143 km within 1 hour. That means that ball can travel a distance of 143 km in 1 hour. That is the meaning of this. Now, what is actually speed? Speed is the distance traveled in unit time. Speed is the distance traveled in unit time. So speed is equal to distance by time. Speed is equal to distance by time. Now, if a body travels different speeds in the course of its traveling, then we take average speed. If a body travels at a non-uniform speed, then the speed of the vehicle will be considered as average speed. Average speed calculated by using the relation total distance traveled by total time taken. Total distance traveled by total time taken gives average speed. It mathematically we represent V average. V average is equal to S total distance T time. So V average is equal to S by T. Once again, what is speed? It is the distance traveled in unit time or rate of traveling distance. It is, we can represent in equation speed equal to distance by time. But most of the case, body travels with a non-uniform speed. Example, a car moving along a street, when it enters into the market or some town, its speed vary according to the obstacles. So we take average speed. How it is? We find out total distance traveled by total time taken. How we can represent this in mathematically? V average is equal to S by T. Here you know S is the distance traveled, T is the time taken for that traveling. Suppose a car travels 100 km in 2 hours. Then its average speed we get as 50 km per hour. This means that car is not traveling at all time 50 km. Sometimes it travels 25 km, sometimes it is 60 km. So its average speed will be taken. We get 100 divided by 2, that is equal to 50 km per hour. Now we can do one more examples to find average speed. Suppose a body travels 16 meter in 4 seconds and another 16 meter in 2 seconds. First it travels 16 meter in 4 seconds, next it travels 16 meter in 2 seconds. We want to find its average speed. First we can find out total distance. Total distance equal to 16 meter plus again 16 meter, that is equal to 32 meter. Now total time. Total time is equal to 4 seconds first plus 2 seconds second. Then total 6 seconds. Then average V average is equal to total distance S5 total time T, that is equal to 32 by 6. We get a 5 point. You know how to divide this one. That is equal to in 32 6 to 5 times remaining 2 into 6. 0.3 again 3 in this way will come. Now to write the unit of speed is meter per second. Here it is given distance in meter and time in second. So the unit is meter per second. Before we wrote kilometer per hour because the distance is kilometer given in kilometer and time in hour. Here distance given in meter, that is 32 meter and time 6 seconds. So 32 meter by 6 seconds. So meter per second is the unit. If it is given in, it can be represented as meter per second. In this way also we can write it also read as meter per second. Another one smaller unit is centimeter per second. Centimeter per second and also kilometer per hour. Kilometer per hour also given as the unit of what is speed. So now we got the idea how to calculate average speed of a body. Now speed, here only distance. When we consider speed with direction, it is called velocity. When we consider speed with direction, that is distance with direction, it is called velocity. Speed with direction. So velocity is the rate of displacement. Otherwise, displacement in 1 second. Displacement by time. Velocity is equal to displacement by time, or V is equal to S by T. If a body is traveling along a straight line with a variable velocity, that is its magnitude changes, then we take average velocity. We know that is when a body is moving along a straight line, its direction is not changing, but its speed may changes. So in that case or other cases, we take average velocity. What we take average velocity equal to initial velocity. Initial velocity plus final velocity by 2. Initial velocity plus final velocity by 2. That means V average is equal to U is the letter representing initial velocity. V for final velocity. So V average is equal to U plus V by 2. It's a unit also. That is unit of velocity is also displacement of we measure in meter and time in second. So it's a unit also meter per second. Otherwise we write this also meter per second. Or sometimes if the distance is given in centimeter, then centimeter per second. If the distance is given in kilometer, then unit is kilometer per hour. Okay, student. Now we can wind up today's class with once again we can record the points which we go through. First we understand the term what is thrust. Example with the watt. Next motion. every object under motion most of the time. Then distance. Distance means only with the magnitude. So it is a scalar. Displacement means a distance with the direction. So it is vector. Then uniform motion. Equal distance traveling in equal time. Then non-uniform motion. Equal time, unequal distance travel. Equal time, but distance travel is unequal. Then speed. Speed is the distance traveled in unit time. Then average speed. Sometimes speed is not in uniform. Then we take average speed, and the unit of it is meter per second, centimeter per second, kilometer per hour. Then velocity. Velocity is the displacement in unit time. Most of the cases velocity is not uniform, so we take average velocity. Average velocity is the initial velocity plus final velocity by 2. Unit of these two remains the same, but speed is a vector. Speed is a vector quantity, but velocity is a speed is a scalar quantity. Once again, speed is a scalar quantity and velocity is a vector quantity, because speed is distance by time, so it is a scalar. Velocity is displacement by time, so it is a vector. Okay? Try to find out more examples from your surroundings.